guys, here we go. We're going to start looking at this most recent test. Okay, I did not fill in this part of it. I don't think I needed to. Okay, and really I wanted to show you how you can answer the questions on the test without consulting this. Okay, so let's go and take a look. Okay, the sign of 7 pi over 3. We want to take a coterminal angle of that, back that down by 2 pi down to sine pi over 3, which is a known value, radical 3 over 2. Likewise with cosine of negative 11 pi over 6, I can add 2 pi, which brings it up to cosine of pi over 6, which is a reference angle right there. Same thing here. I can downsize this by taking out 16 pi over 4, which is 4 pi, which is 2 revolutions, brings it down to the tangent of pi over 4. So those are just reference angles that I found right away, and they're quite, sorry about all this, uh, straightforward, okay? Likewise, coming down here, negative 13 pi over 3, adding 12 pi over 3, or 2 full revolutions, I get cosine, and then of course the secant, so I make it 1 over the cosine of negative pi over 3. Okay, negative swings me, negative pi over 3 swings me in the fourth quadrant, where the cosine is positive, so it's 1 over 1 half, as you can see, or 2. Okay, 22 pi over 4, again referencing that by adding 16 pi over 4, 4 pi, so it drops it down to 6 pi over 4, and that's 1 over the sine. 6 pi over 4, of course, reduces to 3 pi over 2, which is, of course, on the negative y-axis, so of where the sine value is going to take on negative 1. 1 over negative 1 is negative 1. Okay? Negative 5 pi over 6. Okay? Negative is a clockwise rotation. Throws me into quadrant 3 with a reference angle of pi over 6. Okay? Okay, in quadrant 3, the sign is negative, so that value is negative 1 half. Cotangent 38 pi over 3. Of course, I immediately reference that with a 36 pi over 3, or 12 pi, or 6 full revolution. So that takes me to a 2 pi over 3 reference. Okay, and it's I put it as 1 over the tangent. 2 pi over 3, of course, puts me into quadrant 2, where the tangent is going to be negative, and so the tangent and the reference angle is pi over 3, which is root 3, so it's negative 1 over root 3 and rationalize. 38 pi over 3, same reference, 2 pi over 3, sine's positive, that's second quadrant. Okay, pi over 3 is the reference angle, radical 3 over 2. Cosecant 21 pi over 2 negative, of course, I'm going to back that out with adding up some values to make that invariably negative pi over 2, which is, okay, on the negative y-axis. And it's 1 over sine. 1 over negative 1 is negative 1. These are what we learned is verifying some identities. Throw those values in. They were pretty straightforward. Determine the solutions to the sine equaling 1 half within 1 revolution. So here's my graph of the sine. It hits 1 half twice, okay? And those two values occur first at pi over 6. The sine is positive in both the first and second quadrant, so pi over 6 reference in the second quadrant, pi over 6, okay? For what values are the cosine and the secant equal? Well, again, we remember what the cosine looks like. Remember how we graph the secant. So they're meeting at those high points, okay, which occurs at the beginning, middle, and end of the cycle, okay? So it's 0, pi, 2 pi, or every multiple of pi, okay? Determine the solutions to the cosecant of theta equaling root 2 over 2. Okay, that's the same as asking um, when is the well, one is 1 over the sine equal root 2 over 2, or when is the sine equal root 2, which is never going to happen. Okay. Um, Number 5. Uh, for what values of theta is the tangent undefined? Okay. From negative pi to 2 pi. So remember, the tangent is sine over cosine. We graph the cosine graph. So the tangent is going to be undefined wherever the cosine, the denominator, zeroes out, which is, of course, at pi over 2 and 3 pi over 2, owing to the symmetry of the cosine graph across the y-axis that picks up at the negative value. So we have plus or minus plus or minus pi over 2 plus or minus 3 pi over 2. Cosine of theta equals 710, which is have to construct the right triangle. Cosine is the adjacent over hypotenuse, so that's 7 over 10. Pythagorean theorem tells us the missing side here is root 51, so the tangent of theta is radical 51 over 7. Okay. If the sine of theta is a, then what is the tangent of theta, assuming we're in the first quadrant? Okay, everybody's positive in the first quadrant, so no worries there. Okay, similar approach to number 6. Sine is opposite over hypotenuse, that's a over 1. Missing side by Pythagoras is 1 over the radical 1 minus a squared. Tangent is opposite over adjacent. I don't need to worry about rationalizing it. Okay. Determine the arc length. Arc length is the radius times the radian value, so 2 pi over 3 times 12 pi, 8 pi. Okay. Determine all solutions to sine theta equaling cosine of theta. Um, what I did here is in 0 to 2 pi, so we know that sine and cosine share that pi over 4 value, okay, root 2 over 2. But we know that so we're looking for anything that's a pi over 4 reference, but the pi over 4 reference, it means that they have to be of the same sign, which is only occurring. Sine and cosine are only of the same sign, SIGN value, uh, in the first and third quadrant. Okay, so we want those values to occur for those hits on the first and third quadrants. Okay, so that's what we got with that. All right, and then lastly, okay, if the cosine is negative 4 over 5, and okay, the cosine is negative because it's occurring in this third quadrant. Okay, we want the cosecant. Okay, so in the third quadrant, um, only the tangent is positive, so the cosecant is definitely going to be negative. The right triangle suggests a 3, 4, 5. Okay, so the cosecant is 1 over sine. The sine value of that angle is, of course, going to be opposite over adjacent, so it's 3/5. It's negative. It's the reciprocal is 5/3. So there's your test right there for you. Okay.